Welcome to Superheroes of Science. I'm Stephen.
And I'm Sarah. We co-host Science from the Experts. Our guests are professionals doing cutting-edge science right now.
They're experts in their field discussing what they know best. So listen up and learn real science from real people.
Subscribe now and stay informed of our latest episodes and show your support.
Joining us today on Superheroes of Science, we have Brandon Pearson from NearSpace Education. So thanks for being here again. We're hosting you again a second time. We had so much fun with the satellites. We want to ask you some more questions. Yeah.
It's cool stuff.
All right, we're going to cut to the chase.
Yeah.
Because why we have you here, what we wanted to know is, today seems like there's a lot of information in the news about about balloons.
Yes.
I'm not going to say weather balloons. It's just about these mystery balloons that's going around and stuff like that. And I've heard a lot of things. Well, we shouldn't allow any balloons, these weather type balloons, to be launched over the U.S. And there seems to be a lot of people talking, but they don't seem to have much information. And so we brought you back because you do have that information.
Kind of an expert.
Well, I don't know about that, but I have had. Now, I was in that same boat before I got into all this. I didn't understand. I knew about balloons general. I knew that little stuff was happening, but you just don't think about their use. You don't see them for how small they are in the sky, that kind of stuff, until you actually start getting into that world a little bit more and you start diving into just the applications and use and that kind of stuff. So when it comes to the actual balloons that are happening across the U.S., almost all of those balloons that are actually taking place are used for weather prediction, meteorological use, that stuff. The National Weather Service, NOAA, and those kind of organizations, and all comes directly from on their website. They have this stuff posted for people to go out and to see that are curious. They send up 2 balloons every single day from across 90 different locations in the U.S. and the U.S. territories. So there's 65 places here in the U.S. that they go and they send up a balloon at 6 a.m. in the morning and 6 a.m. at night. And these balloons are carrying small little instruments called radiosondes. Now this is a very old-fashioned version of a radiosonde. It's about, I'd say if you took a cereal box and you cut it into kind of a third, that's about the size that we're dealing with. Okay. This one is back in like the 1970s, 1980s. It's a surplus one, but it's doing the same thing. It's using radio signals, hence the name radiosonde, to transmit down atmospheric data, temperature, pressure, relative humidity. Some of them could do wind speed. Some of them could do cosmic radiation and waves, those kind of things. And the reason why is because we're really good at picking up data from the atmosphere on the ground. But so much of our weather takes place way above our heads.
Yes.
And if you're talking about the different layers of the atmosphere, and you look at this first bottom layer that's called the troposphere, where all of our layers and all of our weather comes in, that goes up 30, 40, 50,000 feet depending on the time of year that you're dealing with. And in that level of the troposphere, when you're getting all these clouds and those things that are building up, that's where all of this weather can really get to be. So when we have these massive weather fronts that are coming through, when we're talking about the massive thunderheads that are, hundreds of feet high kind of things stacked up with clouds in the air, that all has to do with weather patterns that are taking place thousands of feet above our heads. Well, how do we get that data, and how are we using that to go and to predict the weather that's going to happen tomorrow or next week? That's where these devices are coming in place. So the National Weather Service, other astronomical societies, there's actually over 900 locations around the world that launch these radiosondes twice a day to collect that vital information so that we can use that to predict, hey, what's the weather going to be like tomorrow? What kind of things with air pollution, as we're looking at that tomorrow, data collected relating to climate change, that kind of stuff. So this stuff is happening all the time. It's just not very many people are aware of it because of the size that we're dealing with, and not very many people will come across finding them because of the research that's done, and because it's just, you're talking with such a high altitude above your head, you're not even aware of what's taking place.
So are these like littering the landscape? If there's that many balloons being launched, are they just like littering the landscape with them or something?
So what happens with a lot of those is those balloons are designed to completely disintegrate. They break, they pop, they completely disintegrate again, because you're right, that would be an that'd be an environmental concern if that was taking place. Now, I know one of the big things with NOAA is that for their radiosondes, when they would come back down, they actually would attach a mailing package onto the side of them that would allow you to then go and you can mail it back to them. So it's already been prepaid postage, you stick it in, send it out. they're also not dealing with anything in terms of actual lethal or anything extra kind of contaminants or that stuff that
No
would be
hazardous
bad for the
stuff.
environment. But yes, that is something that is, even when you talk about the parachute, when it comes back down again, that's biodegradable, because you don't want these kind of things to get to be an issue with littering the land.
Yeah.
Right.
What's different about the balloons that we fly, when I started first as a teacher and now in the NearSpace Education and the groups that I'm working with, is we're actually tracking our balloons and we're retrieving them. So we're not leaving these balloons laying anywhere on the ground. Now, if we were sending up multiple balloons a day, that would be a lot harder. But in our case, we send up once a balloon every now and then. We go, we can track it the entire time during the flight. We go to where it is, we pick it up, we pick up all the pieces, and then we bring it back again, because we want the equipment back. We want to be good stewards of the environment we're in as well. We want to keep using this amazing resource we have for this data collection.
Now, what data are you trying to collect?
So there's a number of things that get to be really, really interesting when we talk about the atmosphere. And like I said, exactly where the troposphere ends kind of things changes a lot back and forth at the time. But as you get up through the troposphere and now you get above the stratosphere and you get above that ozone layer, now we're talking about some really, really interesting conditions. So the temperature, whatever your ground temperature is, when you start going up through the troposphere, you're going to get all the way down to around negative 60 to 80 degrees Fahrenheit. And then right when you hit the troposphere, you hit a spot called the tropopause, and the temperature flips and actually starts to warm back up again up to 32 degrees Fahrenheit roughly. And that rapid temperature change gives you some really good opportunity to test equipment, especially if you're looking at anything that you're interested in going into space later on. We can talk more about that in a second. But then you're also looking at dramatic changes to pressure as it decreases. You're talking about dramatic pressures changes to water vapor as you go, and once you pass through the troposphere, you have basically no water vapor left at all whatsoever. So your humidity is all the way down to zero. And then once you get above the ozone layer, now you're talking about direct blasting from the sun in terms of UV radiation, cosmic rays, and that stuff. And yes, there are additional layers in areas of the atmosphere, such as the magnetic field, that help dampen those things. But obviously, we all know the ozone layer plays a significant role in filtering out a lot of that really radioactive and also just hazardous wavelengths of energy that is coming down as well. So if we can get above that, and we can stick an experiment for a half hour or an hour or longer above that ozone layer, now we really get some unique opportunities to test that direct impact from the sun.
That makes sense.
Yeah.
So, but now you've launched like 30 balloons or something like that, you said, right?
Yes.
When we were talking before. And so are you launching just to test equipment?
The big thing that I'm using them for actually has to do with getting students opportunities to experience some really, really unique interactive ways to do authentic research that they normally don't get the opportunity to. So I got into this while I was teaching high school science classes at a school here in Lafayette. And I was seeing a need for my students to get really real world application for what they were learning. They were doing great on the content, but what you can do with the content matters more nowadays than just actually learning it.
Yes.
And these kids were interested in going off to Purdue, into engineering or other fields that were STEM related and that stuff. So I'm like, what can I do to go and to provide my students with an authentic, hands-on learning environment that allows them to really take ownership of their own experience and get some practice in actual research methodology. And I attended a balloon launch over at Taylor University, and I'm like, this is an incredible resource to be able to allow these students to do these things, because it's so easy to run. It's very, very cost effective once you go and you have the upfront cost to move from there and to redo it multiple times. And there's just a lot of flexibility that the students can have in terms of what kind of experiments they want to test. So over at Faith Christian School, where we're doing this at, they have done 14 balloon launches now, all just flying student experiments, where they're coming up with ideas, we're testing it, they're analyzing the data, they're redefining their experiments, with the goal then of them having a final kind of almost portfolio piece at the end of, hey, here's the research that we have been doing. And that is what other schools are interested in jumping in as well, or some schools want to just do a one-time kind of thing, like, hey, let's just give our students a unique experience just within kind of a week to be able to go into put some things on a balloon, fly it, they go through the process, come back down again, and then we'll go back to our regular stuff. So we've done groups with that as well. The other thing that we're using these balloons for is we're actually using them to test the equipment that eventually is going to go up on our satellites. So last time I was here, we talked about CubeSats and those small little boxes that NearSpace Launch was making, which is the kind of for-profit version of the NearSpace Education.
I'm gonna say, let's
Yep.
real fast, because a lot of companies and corporations, they'll also have like a foundation side
Correct.
or a secondary.
Yes.
Now, NearSpace Launch,
NearSpace Launch has been around since 2014, 2015, when they went with Taylor to help build Indiana's first ever satellite. They build CubeSats, they build other satellite parts. Over these last almost 10 years now, they now have 100 satellites that have made it to space and have sent over 800 parts, what we call systems or subsystems, to space as well.
okay.
But it came out of the educational setting, and they were doing balloon launches to test their equipment, and the founders were using them at Taylor to go and to promote the student learning as well. Well, as the company kept growing, and then everything with COVID, when stuff was getting shut down with hand-based learning and that kind of stuff, and we were coming back out of that, they saw the real need to go and to really pick back up in this education because of the opportunities for students.
Mm-hmm.
And the decision was made, like, let's separate that out into a separate entity that can just focus on education, outreach, student involvement in that, and that's where the NearSpace Education came from.
Okay.
So as the director, we're going and we're taking everything they have done from sciences and atmospheric and space and those things that all the engineers are working on, and we're bringing it into the classrooms for people to use that kind of stuff.
So bringing it into the classrooms, how are you? And I realize this is going into the weeds a little more than I
No.
said we would.
That's good.
But how are you bringing it? Let's say that my kids go to school X, and it's like this would be an awesome opportunity for them. Their science class, their teacher does a lot of amazing things, and I think it's something they would like. How would they get that into their classroom?
So it could be as simple as just coming in and talking about some of the stuff we're doing and showing some satellites and those kind of things. It could be working with us to do a one-time balloon launch, or it could be supplying the equipment and curriculum and support needed to do as many balloon launches you want on your own over and over again. Also, some of the other additional things we have is that we're looking at starting, we have space camps that we'll do, where we'll have people come in and they get to actually use the equipment where the engineers are building their satellites. They get to test it on the same stuff the engineers are testing their satellites on, go through some of the exact same processes. We work with other groups such as museums and those that are interested in incorporating some of that into the stuff that they're doing as well. And then eventually the goal is to get these schools actually back into space through satellites. And that's where we're developing a lot with using those smaller satellites that are called ThinSats that were perfect for student design. Where now we're not just talking about these students flying balloons, but now they're actually flying actual space missions and using that to lay data collected in outer space.
Very nice.
Yeah.
Very nice. All right, I think I sidelined just a little bit. I wanted to know, because I think it's important for people to know that there are a lot of companies, a lot of big companies out there that are interested in helping education.
Mhm.
They're interested, and yeah, part of it's because they're nice, but it's bottom line. It's they need that pipeline into
Yeah.
the STEM careers.
Absolutely.
Yeah.
And
So-
that's the big thing that we're seeing across all these industries that are happening, is even if we have people who have the content, they don't know how to use the content, or they haven't developed the skills. You hear 21st century skills, you hear about, those kind of things that these kids need to be able to be creative, to collaborate, to critical think, that kind of stuff, that we've lost some from COVID and from other methods of teaching now. They're like, hey, how can we go and expose these kids to what's going to be needed so that they can overcome the challenges that tomorrow is going to present?
Yeah.
Because we live in such a dynamic world. I mean, COVID showed that to us and introduced a whole new area of challenges and things in the healthcare system and all that stuff that we previously hadn't had to deal with. So now, as we're preparing not only just as a country, but then also as a world in general, how do we go and prepare for those new challenges coming up? And those 21st century skills, those STEM skills, those engineering skills, those are the kind of things that lots of people believe that this is what we need our employees to be able to do. This is what we need our people to be able to think in order to overcome those dynamic challenges that are in the future. So the whole goal we have is to inspire students to just kind of expose them to some things available that they don't know is available to them. If you're talking about, underrepresented students, you're talking about rural students who don't have access to resources like Purdue, this great place right here, because they live too far away. You're talking about women who normally aren't involved in STEM, that kind of thing. Just exposing them to, hey, this is stuff you can do. You can actively participate in this in a very relevant way. And then for those who are interested, well, now let's actually help you develop some of the skills that is going to set you up for success later on. And that's kind of all the stuff in there. And the ballooning is a fantastic way to go about doing that as well, because you're doing relevant work in an area of the atmosphere that is so dynamic that there's really no way to predict what's going to come down, and you get to drive your own experiments and that kind of stuff.
Well, so you get the balloon up into the atmosphere. How do we? Is it just anyone is free to do that, or is there a communication that has to happen to make sure people know that you're putting the balloon up?
Yeah, we get asked that a lot, especially recently because of the events that have taken place. There are regulations in terms of what you can fly on your balloon, and there's different things in terms of weight requirements. Like, for example, the balloons that we're flying, you can't go and have more than 12 pounds of payload overall. None of your payloads can be over 6 pounds individually. There's surface to weight ratios, all those different things. You can't fly anything hazardous. You can't fly anything like as a cell phone that's transmitting a signal, just like when you have to put your phone on airplane mode when you're in an airplane, that kind of stuff. But the other things that we go and we do to go above and beyond, for example, when I was launching balloons right here in Lafayette, is we'd call all the local airports. I'd call, like the 2 days before, I'd run a projection in terms of where is my balloon going to land. And I follow that projection for like a week, every single day updating it, so I feel very confident it's going to land somewhere within this area. And then I'm calling, at least where we're at, Purdue Airport, Indy Approach, Indy Air Traffic Control, Grissom Air Force Base in Kokomo. I'm calling Chicago Center because they own the airspace even above Indy Approach where we're at as well. And letting all of them know, hey, this is happening, so no one is surprised when these balloons are going up, and no one is questioning what is that object because they've already been notified. There's worksheets that we go in when working with other schools that go directly to the FAA that we fill out, and we're working with those people to provide them with descriptions of the balloon, when are we launching, what is the projected flight path, that kind of stuff, so that nobody is surprised when it's coming. And then with our system, we're able to track the latitude, longitude, altitude, and speed of the balloon up to every 30 seconds throughout the whole time it's flying. And that can go directly onto the internet. It can be pulled up directly onto my phone, that kind of stuff. And then I also fly a backup GPS as well, just for an additional insurance measure, so that I don't run into any issue like I don't know where this thing is coming down.
Mm-hmm. So what all are you flying? What all?
Yep. So you have the main flight balloon, which is up on the top, and this is just an example of one. This is an 800-gram balloon, it's been called, and it's going to get big here for a second. So you can see the size this is. When inflated, this is about 4 feet on the ground across.
Okay.
When it pops, it's going to get up to 20 to 30 feet across as it keeps expanding. And we can talk more about that in a second as well. But we have our main flight balloon that is lifting all the payloads up off the ground. We have a parachute underneath it that we make sure will stay open and doesn't get tangled on the way back down again. We'll have our tracker, and this tracker actually connects to a satellite network up above, which is one of the things we talked a little bit about last time with the CubeSats, is there's the constellation of satellites that are up there that we use for our own GPS, that we'll use for like SOS communication, those kind of things. We're tapping into that so that we can have direct satellite connection when it's flying. Then we'll go and fly whatever sensors we're using. This is actually ones that my students would fly, where we would just use a simple microprocessor board that's inside of just a waterproof box with the battery. This allowed us to collect temperature, pressure, humidity, UV radiation levels, those kind of things. And then in this case here, we also had our backup GPS tracker. And this actually has one of the students' experiments as well on it, because they were testing how battery voltage was impacted by those harsh temperatures. And they were testing different types of batteries, from rechargeable batteries to lithium to nickel alkaline and those kind of things. And then obviously my favorite part is getting the actual footage. So we'll fly something that's got a camera on it. And we've had a couple different ones. We'll have some that are just stationary cameras pointing 3 different ways. And then this one here is actually a 360-degree camera.
Okay.
And we're getting this already because we want to get some really good footage during the eclipse. And then underneath that is all of the student payloads, whatever they're flying as well.
Now, to fly one during the eclipse, that's going to take some timing?
It will take some time. Unfortunately, we have a lot of prediction. Like, we all know when the eclipse is going to happen.
Yeah, and
We
where?
already know where it's going to be. The sun is very predictable in that way. That's not just going to jump and shift 2 states over last minute. So, I mean, this is stuff that's been planned out for years, and there's been task force and those things. I know you guys serve on task force. I'm on 2 different task force with the American Astronomical Society, and we're working with our local NASA representation here as well on how to maximize basically the impact that we're going to have with totality going directly through Indiana here on that time in April 8th next year. So we know when it's going to happen, and a big part then we have is how can we get as many students involved. So right now we're up to 15 different schools and groups that are going to all be launching balloons at the same time during that total solar eclipse, that are going to be able to have that live data transmitted back down to them with their experiments. And then here's the best part about it. Let's say it's cloudy. If you look in the past history, the month of April, on average, is about 50% cloudy, at least here in the Midwest.
Yeah.
So you're flipping a coin depending what the weather's going to be like that day. But if you can get above the cloud line, which usually happens after the first half-hour flight, I don't have clouds anymore. And now I can see the eclipse from above the cloud line, and I should not only be able to see the eclipse, I should be able to see the shadow of the eclipse shining back down on the Earth as well if I have a camera pointing back down too.
Wow.
Which will be a whole different perspective to look at. So there are lots of universities that are working on some big initiatives as well in terms of this kind of stuff. There's obviously NASA's doing. NASA just announced they're going to be doing a big event over at the Indy 500 on the day of the total solar eclipse. But in my mind, I'm like, why can't we get high schoolers and other groups involved as well? So we got elementary, middle school, high school, we got museums, we got homeschool groups, we have universities that are all going to be participating in this kind of balloon launch collaboration. And we're looking for ways to constantly keep expanding that as well.
Well, excellent. Excellent. Thank you. Thank you. This has been informative.
Thank you for listening to this episode of Science from the Experts from Purdue University Superheroes of Science.
If you like this episode, subscribe, give us a positive review, and share the love. Boiler up!
Hammer down.